Okay, so I'm making this video for the analysis of RL circuit, how we can make RL circuit on the simulator. The name of the simulator which I'm using here, that is Multisim. So you can download this software of Multisim and you can install it in your PCs and laptops. And once you'll install it, and after that you can show the implementation and analysis part on the software also, but it is going to be a bit time taking process. So it's very important in the lab you can online open this simulator and you can implement the circuit on it and you can show the analysis of RL circuit on this online simulator. Okay, so let's start with this. So you on Google you need to type Multisim. Once you'll do that, the very first link which will appear, which goes by the name Multisim Live Online Circuit Simulator, you need to click on it. Once you click on it, it will take you to this particular page, and here you need to click on sign up for free. Once you'll do that, it will basically ask your email ID, and with the help of any email ID you need to log into it. You need to create account onto it. It's a very simple process, and then you'll reach to this particular page. As such, I've already logged into it, that's why this particular page is appearing. So once you log into it with the help of your email ID, you'll get the same page. After that, you need to click on create circuit. Once you click on it, it will take you to the main page where you're going to make the circuit, RL circuit or other circuits if you want to make, like RC or RLC. Okay, so now the very first thing which you need to tell student, they have to write here, this is like now untitled circuit, so here they need to write their names and UID. Okay, that is very important part, because when they'll take the screenshots after making the circuit, it's very important their name and UIDs should appear on the top of the screenshot. So here they need to write their UIDs and name. Okay, so now let's start with the making of RL circuit. So the very first thing which you need to do, you can place all the required components here on the main platform. So starting with I need a voltage source. So what can I do? Here we have sources. Once you click on it, all the sources will appear. So here I need AC voltage source. So I'm just dragging and dropping it here. It's very easy, like we do it in Tinkercad. Okay, so once it will come here, I can basically do the necessary changes. For example, right now this is voltage V1. So by clicking on V1, I can change its name. So I can give it a name like simple voltage. And when you press enter, as you can see, the name has been changed. You can change the value of voltage also. Right now it's 1 volt, but here we are giving the voltage as 220 volt. So 220. You can directly write it here and you can change the voltage. Once you'll press enter, 220 volt will appear here. Otherwise you can drag this particular thing here and take it to the particular voltage which you want to give to the circuit. And let me change the frequency also. Right now it's 1 kilohertz. So when you click on 1 kilohertz, the frequency will appear, and simply going here and let's say I'm giving the frequency 50 hertz and let's press enter, and here as you can see I have done all the necessary changes. Okay, so now the next thing which I need ground, because once I'll complete the circuit I need to give one common ground. So let me drag and drop it here. For the time being, let's place it here. And now I'm doing the analysis of RL circuit. So obviously I need resistance and inductor. So here I need to find out these passive components. So here it goes by the name passive only. Once you click on it, all the passive components will appear here. I need resistor. Let's drag and drop it here. And for the time being, let's place it here. So it's a resistance of 1 kilo ohm. and it is R1, so I can change its value. So right now I'm taking the values as 500 ohm. Later I'll tell you what is the significance of taking the different values, how it is going to affect our analysis of RL circuit. I'll come to that part later, but for the time being and for the reference point of view, I'm taking the value of resistance as 500 ohm. So once you'll do that, the next thing is I need inductor. So let's take the inductor here and let's drop it here. Okay. So this is the inductor of 1 microhenry. So let me change its value. Okay, just give me 1 second. Okay. So here, for example, I'm taking the value right now 20 millihenry. Okay, I'm changing the value to 1 microhenry to 20 millihenry. And by clicking on inductor and by pressing the R from your keyboard, you can simply rotate it like you used to do it in Tinkercad, when you have to place the component in a different manner, not in the horizontal manner. Let's say you want to place the component in a vertical manner. So you press R here by clicking onto the component. 1 second, that's coming the same component. Let me delete this first. 1 second, let me delete the resistance also. Let me just bring back the inductor again here. Now this, and I want to simply rotate it. So here we have the option, or by pressing Shift plus R you can rotate it. So let's say this is the position in which I want to place the resistor in the circuit, sorry, the inductor in the circuit. So once you'll do that, now I have to make the connections, and it's very easy, guys. So what you need to do, you need to click on this point. As you can see, the hand is appearing here at the one terminal of the voltage, that is the positive terminal. Once you click on it, this particular symbol will appear, and you need to just, with the help of your mouse, you need to take it to the specific position where you want to make the connection. So it's very easy. So now the very first connection has been done, and it goes by the name 1. Next connection which I have to make, I want to make the connection of resistance. So I'm clicking at this terminal of the resistance, and this symbol will appear, and now I'm taking the connection to the particular point of the inductor like this. And then last connection which I'm making, it's the negative terminal of the voltage. I'm clicking on it. Once I'll click on it, 1 second, yes, so once I click on it, it will appear like this. So now I'm taking it to the particular point where I want to connect it with the inductor. So once this particular thing is done, now I can simply drag and connect the common ground here like this. So here I have just made the RL circuit. It's very easy. Similarly, you can make RC circuit. Similarly, you can make RLC circuit. That is up to you. If you want to show the students the analysis of all the 3 types of circuits, you can do that. Okay, so once this particular thing is done, now let's go to the analysis part of this circuit. In order to do the analysis, if you click on grapher, it will show you the entire graph where you're going to get the waveforms. So from those waveforms, you can basically tell the relationship of voltage and current between across the resistance and inductor. But at the same time, you are not able to see the circuit. So it's very important. Rather than going for the grapher, you can go for split. So once you click on it, you will see both the things will appear here on your screen. As you can see, it's your circuit plus the graph or the voltage or current relationship, which you'll get in the form of the waveforms here. So both the things you can see simultaneously, and it is very easy for you to tell the students the relationship between voltage and current across the elements which we have connected in the circuit. Okay, so now the next thing which you have to do, 1 second, let me change the value of the inductor. It's again 1 microhenry. Let me change it once. Let's say I'm taking 20 millihenry. Okay, let's click on this. Okay, so here the value of the resistance is a bit high as compared to inductor. In this particular scenario, the overall circuit is going to show me the resistive behavior. So that means the voltage and current which I'm going to see here on the graph, they are going to be in the same phase because resistance value is bit high. Okay, so that's why you need to take the different value of the resistance after this, where we can show the circuit inductive behavior. Okay, that part comes later. Let's stick to this part. So now, as such, oscilloscope is not present here. Means the option of dragging and dropping the oscilloscope is not present here in this online simulator. It is available if you download the software and install it in your PCs. But the other option is there. So the option is, once you click on this green symbol of voltage, that is analysis and notation, once you click on it, so here you can see plenty of options are coming. So as such, I want to see the voltage current relationship. That's why I'm picking this particular option. As you can see, this particular option will appear here like this. So you need to drag it and you need to just drop it here like this. Once you click on it, the connection has been established. So it show me the voltage and current relationship across the RL circuit, overall RL circuit. Just the value of the resistance is high. That's why I'm going to get the voltage and current in phase with each other. Okay. So let me run this. This is the run simulation. So once you click on, so right now the values are changing very fastly and I'm not able to see in phase relationship between voltage and current. So I need to do little bit changes. So what I have to do, so trigger, here you can see we have plenty of options for trigger. Click on single, so it will stop the waveforms. Okay, this shows the edge direction. Okay, I mean from which particular point you want to start your waveforms. And here you can see, here we have voltage and current relationship. So right now time slash per division, it is very less. Let me increase this. So I'm able to see the in phase relationship between voltage and current. Still the magnitude of the voltage and current is very high, so that I'm not able to see the waveforms. So little bit changes you have to do. So here as such, this is 220 volt, that is nothing but the RMS voltage. So let's take 220 volt here, that is the minimum voltage, the magnitude of the voltage. Okay, so 1 second, it's, let's write minus 220 because that is the minimum one, so that's why it is minus 220. And here let me write 220. So now you can see the voltage waveform. And let me change the value of the current also. Let's say the minimum value of the current I'm giving minus 1 ampere and the maximum value of the current I'm giving 1 ampere. So once you click on it, now you can clearly see the phase relationship of voltage and current, and this is showing me the resistive behavior of the circuit because voltage and current, they are exactly in phase with each other. You can see they are in phase with each other. Okay, so as such we are analyzing the phase relationship voltage and current, so that's why I'm not basically going into the magnitude part of voltage and current. You can change the magnitudes also and you can see the different shape of the waveforms. Okay, so once this particular thing is done, you need to tell the students this is the very first screenshot they have to take, which showing the behavior of RL circuit as resistive only due to the value of the resistance is very high. Okay, so the next thing which we have to do, now I'm changing the values of resistance. Okay, let's keeping the value of the resistance same, let's increase the value of the inductance. So here right now I'm taking 20 millihenry. So let me stop this once and let me change the value. So I'm clicking on it We have inductance now 20 millihenry. Let me take 1000 millihenry, which is nothing but 1 henry only. So let me increase this value, enter. And now by increasing the value of the inductor, what is going to happen? The voltage and current relationship which I'll see here, it is going to be purely inductive. Means voltage is going to lead the current by the angle of 90 degree. Okay, so let's run this and we'll figure it out whether we are getting this kind of relationship or not. So let me run this once. So here you can see the relationship between voltage and current. So here you can clearly see my voltage, it is leading the current by the angle of 90 degree. And it shows the behavior of the circuit purely inductive. So this is the second screenshot which students need to take, where the circuit is showing the purely inductive behavior. So now as such we are talking about the RL circuit. Obviously one thing is going to happen here, voltage is going to lead the current because it's a RL circuit. But changing the value of resistance and inductor, it affects the voltage and current relationship. So we need to take the values where we can show them, yes, voltage is leading the current by some phase angle. So let me stop this. This is the third screenshot they have to take, where you need to change the value. Let's say I'm taking the value from 500 to, let's say, approximately 700 ohms. Okay, let's increase the value of the resistance. And here I'm keeping the value of inductance as 1 henry only. Okay, you can do these changes by yourself also, and you can see the relationship between voltage and current. So when I'll run, so as you can see right now, it's not a 90 degree phase difference between voltage and current, but yes, you can clearly see that voltage is leading the current by some angle. Okay, so this is the entire analysis of RL circuit. 3 screenshots they have to take. Other thing which you need to do, you need to basically explain them how they can calculate the power factor. In order to calculate the power factor, we need wattmeter, but as such the option of wattmeter is not available in this particular online simulator. So you can do one thing, you can basically tell them they can directly calculate power factors. It's very easy, and they have to calculate the power factor for all the 3 circuits. I mean, where they are using the high value of resistance, and then they are using the high value of inductance, and after that the value of resistance and inductance, it's very close to each other, something like that. So in all the 3 cases they need to calculate the power factor. That is nothing but cos phi, which is equals to R by Z. It's very easy to calculate. So you can tell them they can calculate the power factors manually. Okay, in all the 3 cases they can calculate the power factor. And if you want to calculate, if you want to show them the calculation of power factor on the software, then the solution is also there. You need to just download the Multisim on your laptops, and then you need to run its setup. It is going to take some time, but yes, you can show all the things on the software itself. But as I said, it is a bit time taking process. So in the lab we have very much less time, so you can basically show the things here. Even you can cover RC circuit if you want to cover, or you can also show them RLC circuits. And even on this network simulator, you can also show them the KCL and KVL, how they can calculate the current and voltages across the branches with the help of this simulation software. Okay, so that's all in this particular experiment. Thank you.